Welcome to the first ever New Manufacturing Alliance Women in STEM. We're so excited that you can join us today. Today we have three amazing women that will be sharing their story of their STEM career. I'd like to welcome first, who will be speaking, Tasha Poplin. She's with Pioneer Metal Finishing, and she's a research scientist. Tasha, welcome.
Hello. All right.
Thank you.
So here I have a presentation I will share quick. So as Anne mentioned, my name is Tasha Poplin and I work as a quality assurance and research chemist at Pioneer Metal Finishing. My typical day, I'm working on a lot of different research methods for either our current processes or trying to create new processes for our customers to help them with different performance attributes and that sort of thing. I work with a cross-functional team to try to identify new and improved metal finishing processes, as well as working on reviewing customer inquiries and concerns to find better solutions for their specific needs. So our area of expertise, at least in the lab here, is doing anodized aluminum, which is basically putting raw aluminum into a dilute acid bath and then applying electricity to create a aluminum oxide layer, which is essentially aluminum rust, but it's controlled to create this very hard porous coating, which can then be dyed into different colors, as you can see in some of these pictures, and can be kind of specialized to fit certain customers' needs. We also work with a lot of other different processes, plating processes, coatings. So we have nickel, gold, precious metals, that sort of thing as well that we work on. So some of these pictures here, that top picture with all the different colors is just kind of a representation of the different colors we can provide with our anodized coating. And then that little car is just a part that we dyed red, anodized. It looks pretty nice. And then the bottom two are parts that I have worked on recently. On the left, we're trying to develop a process that will match a customer's specific black color. So going into this is a lot of developing a process that will create the correct performance requirements, so corrosion resistance, wear resistance, that sort of thing, as well as providing an aesthetic view that the customer is really looking for. And then on the right, we have some nuts that we were anodizing that initially were having some different colors after we anodized. So we did a lot of root cause analysis and that sort of thing to try to determine why we were seeing differences. And that actually came down to the chemistry of the alloy, the aluminum alloy. So which was just a difference in the concentration of the alloying elements in the aluminum. So I think I've always been kind of interested in research in general because I kind of like the riddle aspect of it. The fact that you have to really use your problem solving skills and kind of think outside of the box to find a process that will, either meet a specific customer's needs in the case of, a color requirement and that sort of thing, or also to, kind of tap into a new market. So if you're looking for, we do some research for medical markets, aerospace, that sort of thing. So we're kind of touching a lot of different areas in the manufacturing world and just the world in general. I think a lot of the information that I use and the calculations and background knowledge that I have did stem from a lot of my base levels in high school with chemistry specifically. A lot of times I have to calculate formulations for our baths and that sort of thing to kind of determine what concentration I need in my baths to create the outcome that I'm looking for. So in this role that I play as well. I also do some material testing, myself and my team. So we have a salt spray chamber, which is essentially a accelerated corrosion resistant tool. So on the left there, you can see it's open. We have some panels in there. We can test any of our processes. It's really to help our customers see at an accelerated rate how well our coatings will hold up in a harsh environment, specifically with salt or you know, a lot of rain, water, that sort of thing. And then we also have a cross-sectional thickness microscope. So what we do is we cut parts into small sections, and then we mount them in a press and then polish, and use a microscope to measure the thickness of the anodize or any other plating that we're looking at the time. So in this picture on the top right, you can see on the bottom is the raw aluminum, which is the kind of like shiny light gray part, and then above that is the hard coat layer or the anodized layer. And you can see that we have an instrument that can measure the thickness of this layer. And then we use this either to verify our thicknesses if we're having some discussions with customers and that sort of thing that we're not aligned on what we think the thickness is. So this is really kind of a referee test on that front, as well as if there's any defects and that sort of thing that we're seeing on these parts. We can kind of look at a closer level to see both how the raw aluminum or raw metal looks, as well as the plating or coating as well. We also do a number of other tests. So on the bottom, this is a Tabor wear test. So what we're doing is we're taking a plated or coated panel and we're testing it with a weighted, basically like a sandpaper on the part, and it twists in a circle. And it creates that circular pattern that you see on the bottom right. This is used again for harsh environments. If a customer is looking for something that is very wear resistant and will hold up in that sort of environment, this is an important test for them. We also can do a number of other tests, including you know, surface finishes, different colors. As I noted, we have a spectrophotometer which measures the LAB color values, which we use a lot for customer specifications. And then we also do a lot of wet chemistry for making sure that our process chemists in the plants are using you know, the best method that we can find at this point to control their baths and make sure that we have consistent quality for our customers. I do think overall STEM careers need a very diverse, you know, workforce and people to think about these things. So I really think having more women in the workplace, specifically in these types of careers, is helpful because we need that, you know, different perspectives. And I see it a lot in working with other teams within Pioneer. Having those different viewpoints and different perspectives is great, and it makes a lot of difference in trying to determine root causes to customer problems, or if we're having other problems in the plants, or even trying to figure out the next steps on research and kind of getting over like the writer's block of research, I guess, where you kind of are stuck. So it's really nice to have others to really discuss that with and have a good relationship with, and build that background and everything like that. So I think that's everything I have.
Thanks so much, Tasha. Tasha is one of our 2021 All-Stars. We have our member companies nominate their best employees, and 1/4 of those people that are nominated actually win. So congratulations.
Thank you.
What classes in high school did you really like that you would recommend for students to consider as they continue their career?
Yeah, so I really enjoyed chemistry. As I stated before, it really laid the baseline. And I also took advanced chemistry as well, AP chemistry, which really helped lay the baseline as well. Also, a lot of the math classes were very helpful. My calculus that I took in high school has helped me quite a bit. But I also think that using working with like creative writing classes and that sort of thing is very helpful. It helps you, at least in my career, helps me to think more freely and helps me to determine, you know, what I should do next and that sort of thing. But I also think it helps with writing reports and having clear communication between, you know, the more technical roles and the, you know, sales, marketing, and, you know, the plant facilities and that sort of thing as well.
Cool. And then where did you go to college?
I went to St. Norbert's.
Okay, great. Thank you. I really appreciate your presentation. And then for the students that are watching, if you want to ask a question, you can put it in the chat box. And then next, we're going to be having Adonica Randall speak. She's an amazing lady, and I can't wait for you to hear her story. She owns a cool company, and her background is second to none. So, Adonica, I welcome you next to speak.
Okay, let's see here. I am going to hopefully share my screen and find the right, and find the right PowerPoint here to do. I'm gonna talk a little bit today about, start my timer here so we stay on time. I'm gonna talk a little bit today about how I got into this field. Adonica Randall, I've been in technology for, and can you see the screen? Because I've got three
Yes.
screens here. Typical technical geek.
Journey to STEMland.
I've got lots of technology sitting here. So how did I end up in tech? I've been in tech probably for the last, I think this is my 47th year. So I've been around a long time. My background is that my undergraduate degree is in computer science and electrical engineering. My master's is actually in electrical engineering and biomedical engineering. It sounds like it's diverse from the engineering field, but if you look on the jobs I've had, I've worked for a couple of companies that people may have heard of, GE Healthcare, which is here in the Milwaukee area and nationally, IBM, which is a global company, General Motors. I worked in the proving grounds where you drove the test cars. Still my best job to date. I love that one. And then A.O. Smith, which what most people don't know is under A.O. Smith, we created the time machines where you go and get your money from. And most folks in Wisconsin don't know that. That actually came from A.O. Smith. We actually created that product set. I've been a college professor for about 23 years. And I've worked across a couple of small businesses, and I currently own my own business for the last 18 years, and we kind of do all type of technology things. I'll tell you a little bit about that. And I'm very big on the STEM aspect, and especially for girls. So how did I get into this stuff? I am a hardcore Star Trek fan. I see Tasha shaking her head. You know, I'm a hardcore Star Trek fan. I love comics. I love Tron. I still love Doctor Who. I am a typical geek. I'd love to get into those things because the one advantage that I found in science fiction was very welcoming. There was always women involved in it. There was always minorities involved in it. And they were always treated as equals. And that's probably one of the reasons I sort of latched on to that. And there was always adventure in those things. As the previous speaker talked about, I like solving puzzles. I like to see what's behind the mystery. And I spent a considerable amount of time in reading the books and trying to figure out how things got solved and how they got done. We can talk a little bit about old school tech. One of the things that you'll find out from the technology side that we did is the old school communicators out of Star Trek looked a whole lot like the phones that first came out in the cell phones once they got small enough. That's not a happenstance. As technical designers, a lot of the things that we made up in science fiction end up becoming science fact. And that's one of the fun things I like about doing this job, is that in the global piece that's out there, you know, we design things that were just pure concepts into technical reality. And as I said, one of the things I loved about Star Trek is on the bridge, you guys are all too young. Everybody that's on this is too young. But one of the key things about that is that there were women on the bridge. There was a minority on the bridge. There were aliens, of course, on the bridge. There was even a Russian on the bridge. And at that time, we were in a Cold War with Russia. So it was a very diverse cast. And we're talking about 1960, which I'm sure for you guys sounds like a million years ago. But we had to start somewhere to get this done. As we talk about the type of projects that you can do with technology, I'm really been involved with technology across a lot of different aspects. The hardware aspect, the hardware that's in the Buck Stadium, all of the technology that allows your network and your phones and all those things to work in, we put that in there. That involved electrical engineers. It involved people stringing wire. It involved connections. There are security doors that are involved. There's all the back-end hardware that's there. GE Healthcare, we've done development work, software development to create new projects. We Energies, we've done software projects that help them monitor the electricity and the lines and the data that comes in. So you've got the software aspect of that if you happen to like to write code. We do a lot of that there. For manpower, we do a lot of work with the state of Wisconsin. The people there do a variety of development work across multiple government agencies with different languages that they work in. For the banks, we've done financial work for them to do business analytics. So if you happen to like the math and the statistical and the analytics place, we do that. The Milwaukee Police Department, we actually run the back end technology code that keeps up with their data. And we also do a lot of their cyber back end. So for folks who really like to maybe be the white hat against the black hats, we do a lot of that type of development work as well. You know, Kimberly-Clark, with the pandemic going on, Kimberly-Clark makes toilet paper. Woohoo! We work with them on their factory lines to make sure their factory lines stay up and running because they're all computerized. So there's a great variety of work that you can do on the technology side when you're talking about STEM. Everything from, if you like the hardware aspect of it, where you're physically touching, building machines, connecting things together, the software aspect where you like sitting behind a desk and you like doing the code and solving a problem. There's the customer aspect of technology. We work with the customers because we're analysts and we have to understand what the customer needs in order to turn that into the technology and the way those things actually work. You have the designers who are designing the internal structures of everything from the machines that are being created to the software architects that are there, to traditional engineers, to the things like Tasha does, which is the chemical. Chemistry wasn't my thing. Loved math. Chemistry, not so much. Background in school, gravitated toward the things that were naturally in the sciences, where the science is leading you to ask questions about the next phase. So there's a big, huge variety of things that you can do in STEM. And I would say, I would add to that, if you talk about the STEAM side of it, where you got the A in there for the arts, I would agree that writing classes are great. You have to communicate. Communication skills, whether they are on paper or verbal or whatever, are critical in order to, because we work in the sciences, we have to be exact, and the information has to be precise. So learning how to do that is great. So, you know, all of those classes have some value. So my timer says I have 1 minute, so I would say that that's where I would end that, Miss Ann.
Thank you, Adonica. As you stopped sharing your screen, thank you. Again, ladies, if you have any questions for Adonica now, you can type them in the chat. I'm curious, because you started in the 60s, you know, at the Star Trek and watching all that cool stuff.
That's right. Still watching it. Still watching it.
What is the biggest change you've seen over the years in terms of women in the workplace?
I would say the biggest change is there are women in the workplace. So let's start there. And they are bringing that diverse problem-solving skill set that we have that's unique to teams in order to solve problems in a totally different way. A case in point would be the Fiserv Forum was a technology challenge for IT especially. Construction sort of operates a little bit like it did, okay, turn off. Yeah, construction operates a little bit like it did 100 years ago. And IT is not really considered by the architects and those types of things. We're sort of at the end. That building, the way it is constructed, was a challenge to put in, wireless access points, the things that allow you to use your phone, and the technology, and the order from your seat, and all of those things. And basically, because we had a diverse team of 60 project managers, which included 5 women, and my team had a woman at the helm, and that was deliberate to put her at the helm. The decision was made with our company as part of a couple of other ones that stadium became the first stadium in the world to have the technology put in the handrails as opposed to up in the ceiling. Seems simple enough, but it had never been done before. You know, because you had women in the group saying, well, why does it have to be in the ceiling? Why does it have to be like this? Why does it have to, okay? So any voices where you're solving a problem, where you have different backgrounds, different groups, different everything, you come up with what the Fiserv Forum is, which for when we built that, it is now the example of how all new stadiums are built with that technology where it is in the rails. So it's one of those things that would they have solved the problem without the women on the team or a female minority company on the team? They'd have solved it. Would they have solved it the way we solved it? Probably not.
Great example. Thank you so much. Next, I'm going to invite Janet Rankin to present. She's a senior manufacturer at KI. Janet was a former All-Star mentor several years ago. So Janet, I'll give the floor to you now.
All right. I'll start with who I am, but I'd like to build a little bit about the women in engineering, because you guys made points that very similar to mine, but I have another example that we have here why it was so important to have women on it. But so I work at KI. We manufacture contract furniture for schools, businesses, colleges, healthcare, and around Wisconsin, UW schools, Austin Straubel Airport, the gate seating, Northwest Mutual Life, the new building that's up in downtown Milwaukee. We furnished basically all of their furniture and movable walls. It was a really, really good project for us. And so some of the things we build besides just student chairs and desks, we have the hideaway tables where, you know, you mount your flat screen monitor on it, and it can hide away, so you can either use it as a desk or as a computer station for having versatile classroom settings. So my role here, I have kind of a dual role, which I think anybody in the engineering field, you don't just go in and you do design or you do, the costing, the industrial stuff. You wear a lot of hats. I'm a manufacturing and quality engineer. So besides the setting up new processes and customer service, helping solve problems once our product gets out in the field, if the installers don't know how to put it together or something isn't working right, or a lot of electronics involved now with height adjustable tables, a lot of things moving. And so day to day, a lot of troubleshooting, a lot of root cause, and that's, Tasha, you touched on that, how important it is that when there are issues that you dig into the root causes. Data analysis, and I think I have the best job because I get to do some coding, I get to do root cause analysis, I get to do anything related to making the quality management system better. I get to do a little design, I get to talk to customers, let them know about different products we have. So it's extremely diverse. But leading into the having women involved, and I've been out there a few years too, Danica. I think I'm 35 years in the industry, and what I've seen is I was one of 2 females in my graduating class. I have a mechanical engineering degree. I was one of 2, and it's funny because I guess I would have thought that has changed dramatically, but it hasn't changed as much as I thought it would, 30 years later. So, not only is it good because women and men do think a little bit different a lot of the times, and we have different ways of looking at things. And so I think overall products and services become more robust when you have a diverse team, men and women, young and older, people who've been out there for 40 years and people who are just fresh, who can really look at things with a young person's perspective. But to give you an example, so we make height adjustable tables where there's a little pad and buttons that you have to push. So it gets through design and prototype, and so you have an evaluation team that's going to try this thing out and see how is the consumer going to like it. Well, I don't keep long fingernails, but a lot of women do, especially women in certain businesses where they're going to be adjusting the height of their table. Well, the buttons on the pad were a little bit recessed, so everybody checked it out, it was fine. There was a woman with a little bit longer fingernails, she couldn't access it, and nobody ever considered that up front. And so I think looking at it from a women's perspective, like when you talk about the stadiums, where's the line always the longest? The women's bathroom, right? So I do think that engineering is transforming from a gendered career as more and more women get out there. And I think that I'm hoping that that also gives young women the confidence to pursue. When I first went into it, I was a little bit nervous. I wasn't always treated well by the peers, the people I had to work with, because I was a 22-year-old girl, and I walked into a male-dominated manufacturing field. Things have gotten a lot better. I mean, it's great. The team here, the culture has changed. So I wanted to build a little bit on that. The diversity, I think, really is key in trying to encourage young women to join this field, because it's fun, because it changes, it's challenging. As far as how I got into this, well, my dad was an engineer, and my parents strongly encouraged it because they knew what opportunities would always be there. Somebody who's good, a good engineer, a good scientist, you will always be employable. You'll always have a good place to work. I liked science, I liked math, and I'm with you, Adonica. The chemistry, not so much. I liked the physical sciences. I liked physics and dynamics and how things stay standing and how things bend or don't bend, how things break and what happens when they break. And so, you know, when I was younger, I liked puzzles and I liked tinkering with bicycles. And in fact, I took apart the carburetor on my first car, and my big brother had to help me put it back together because I wasn't quite talented enough at 16 years old to put it back together. So I think that the engineering and STEM careers in general for women are just, they're great opportunities. And my career has really been diverse over the years. I started out doing design for military ordnance products for defense contractors. It led me into design and analysis and intellectual property, patenting and claim writing for steam injected combustion for cleaner power generation. I did some teaching, high school and middle school level math, which was amazing. And then now I'm with KI manufacturing furniture. What I like best about my job, the people I work with, we have a wonderful team. We brainstorm together, we work together, we have a lot of fun together, we work really hard together. And on any day, I can be answering phones and talking to customers, or I could be out on the production floor helping get a job that needs to get going. And I love putting my gloves on and getting out on the floor. The other thing about my position here is the opportunity to be mentored, because I never stop learning from people. The experiences they've had, and even listening to you two, it's just amazing to kind of hear where you've been and how you got there. And the opportunity to mentor, to tell our story, to let people know that it's great opportunities and it's fun and it's satisfying. And I think that's about all I have, unless, oh, I do have a video. I'm going to try to share it. I'll bring it up. And I guess you just have to let me know if this doesn't work.
Will do.
This is some robotics. Is it sharing?
Nope, you have to think
Oh,
share.
there we go.
There you go.
All right.
Starting. Wonderful, good.
And I have a feeling it's going to be loud. So I'm going to start it and play it for a little bit, and then I'm going to move it forward because it's about 4 minutes. All right. Are you able to see?
Yes.
So this is a robotic cell, and something like this, it looks like automation, but the different disciplines of engineering involved in this, between automation, design, you had industrial engineers for costing. You don't just buy something like this, it needs to be cost justified. So this robot, we're making tabletops here, and what it's doing is it's taking it from the first station where it has the backer and the laminate on, and it's entirely robotically set up. And so there's a backer side and a laminate side, and the tops have to be flipped over and before they can get put on the bed. And so there's two router beds going, and one is going while the robot's going to load the second one. You guys can hear me okay, right?
Yes.
Okay. All right, so then it's loaded up, and then the robot now is just going to wait. And I'm going to move ahead to okay, so now the one is done. The robot's going to take it away. And in order to place it right, it has to flip it over. And so this is just 2 of the stations it's operating. And hopefully next year there will be another set of those router beds that are doing the work on the tops on the other side. So we'll be able to be running 4. But it's kind of neat. It was a great adventure here, and just a whole lot involved. Now that one's ready to go out. There. So.
Question for you. How many people were involved in doing the setting up the robot, building it, what type of positions all were involved with that cell?
Well, everything from, well, the start of it, you have an engineer that has to cost justify it. You have to show what it's going to do financially for the company, and it's not just about production and how many people you need. It's about safety. I mean, there's a lot involved in people handling those big tops and the potential safety hazards. So you start out with an engineer who gets the idea, and there's managers involved, there's automation engineers, there's design engineers, there's manufacturing engineers, production techs, the people who are going to have to run it, that are going to have to learn it, that have a lot of input on the type of interface that they're going to use to control it. Maintenance. Somebody's got to put it all together. Somebody's got to build the cage around it, put all the electrical engineers, of course, put all the safety features in place. I can't think of any particular discipline or department here that was not involved in that project.
Well, it just shows there's so many different aspects to something. It's not so simple. You just buy something off the shelf and put it in.
Right. And as the industry moves this way, we need more of the STEM programs to develop the people, because if you don't have the people that can do the automation or can do the design, you don't have a product.
True. Great. Thank you. As we wrap up, if there's any additional questions, you can go ahead and put them in the chat box. And I really appreciate all three of you sharing your story that really shows that STEM is a great career. And there's a lot of opportunities for women in those careers. Next week, we're going to be having 3 more women share their story. This link will also get you to those 3 ladies that will be sharing their focuses in mechanical and electrical engineer. Thank you so much for joining us today. And let me see, Olivia has a question. Is it harder for your voice ideas to be heard? It's a great question, Olivia. What do you think, Adonica? Is it harder for your voice to be heard?
I think over time you develop, and especially with not as much now, to Janet's point, coming in a while back, you had to be strong enough to stand up for the ideas, because to get your ideas heard. Not as much now. I think more the younger group of folks you're working with are more, I think, a little bit more open. I mean, Tasha may be able to speak to that better, but I mean, obviously, as you go through the ranks and you get more and more under your belt, it's easier for you to express your ideas. Tasha and Janet work for companies. I own the company. Makes it a little bit different about getting my idea across versus somebody else's. But that was a journey. You don't start there, and I'm sure, Janet's a senior level person, that kind of stuff. So the more you progress, the more people tend to, just like anything, the more you're involved with it, people tend to listen to you more, because they know, well, Janet's done that before, Tasha's done that before. I want to hear what they have to say. So I think it gets better over time, and it's a matter of knowing the people that you're working with.
What about you, Tasha, being younger?
Yeah, so I think a lot of times there's kind of a break-in period, as Danica kind of was talking about, where when I first started being young and being a female and where I'm working, there's a lot of older men. And I think it's not so much that I'm a woman, but that they don't know if I really know what I'm talking about, that
Right.
sort of thing. So it was more along the lines of just getting that trust from the other people on the teams, and having them realize that I'm trying to help, and that I want to learn and grow, and really, when I express my opinion, it's not to cause any conflict and that sort of thing. It's really just to help better the company and better the process in general.
Mm-hmm. Thank you. Janet, do you have any other thoughts?
No, I think they covered it. I do know that as I got a little bit older, it was easier, but I can say 35 years ago, just, just walking in as a woman, I have a couple of nieces who are also engineers in male-dominated fields, and they said they were expecting it to be harder than it is. They said that they're not experiencing some of the what they were kind of bracing themselves for.
Great.
So
thank
that's good
you.
news.
That is. Any other questions? Great. Well, again, thank you, Olivia, for that great question. That's a good question. We appreciate you being here today. And if you're interested, be sure to check in on next week's episode. And thank you to Tasha, Janet, and Adonica. I really appreciate you sharing your stories with us. Have a great day. Thank you.